All right, then welcome everyone. Let's go ahead and get started. My name's Dan from Dan's Test Prep. Today, I've got some live SAT questions for you. Mostly going to be doing like some digital SAT questions, but open to whatever you guys submit to me. So anyways, the way it's going to work is I'm just going to go through some of the questions. I'll check with your guys' understanding throughout the session. And we'll kind of just see how everything goes there. So all right, let's go ahead with that. First question we've got is a nice little math question. You guys feel free to answer this in the chat as well. I'm not going to stop you, but I will go through it with you. So this one says the solution to the given system of equations is x comma y. What is the value of x? Well, this one I think you guys should all be able to figure out. What I would do is I would probably set both equations equal to each other because we have both of them equal to y. So that would be negative 1/9 x equals to 1/2 x. So in order for this to be true, what I could do here is kind of just multiply everything by 9 to get rid of this denominator. I can multiply everything by 2 to get rid of this. So common denominator here would be to multiply by 18. Multiply everything by 18, get rid of all those fractions. Well, 18 divided by 9 is going to give us 2. So that's negative 2x. And 1/2 times 18 is 9, so that's 9x. Negative 2x equals 9x. If you subtract, or if you add 2x to both sides, you get something like 0 equals 11x. And from here, it's pretty clear if you divide everything by 11, we just get x equals 0. Actually, that should be clear from these equations as well. They both pass through the origin, so the point of intersection is going to be at x equals 0. Be like right there. So that's going to be answer choice C. How do we do on that one? X equals 0. Yeah. I'll look at some of the other questions you guys submit after I get through all of these SAT questions. So stick around for that for sure. This one is talking about a exponential function g defined by g of x equals 19 times a to the x, where a is a positive constant. If g of 3 equals 2,375, what is the value of g of 4? Okay, I mean, if a is a positive constant, we should be able to solve for it, right? If we know that g of 3, which is just 19 times a to the power 3, that equals 2,375, then we can divide everything by 19 to get a cubed equals, shoot, I'm going to need my calculator for this one, but 2,375 divided by 19 would give us 125. So a cubed equals 125. That means if we cube root everything, a would equal 5. That's not the final answer, but I am going to box it because it's important. The next step would be to evaluate g of 4. G of 4, which is just 19 times 5 to the power 4. So 5 to the power 4 is going to be 625. And multiply that by 19, you're going to get 11,875, which makes that the final answer for this one. Hope you guys got all that one. Light work? Yeah, exactly. You've got it. Okay, this one says the solution to the given system of equations is x comma y. What is the value of x? Here, maybe you guys can get it in a chat faster than I can explain it. I mean, definitely, I think you can. Yeah, 18 is correct. And For anybody still working on this one, I can show you that 3y equals 11. And if you directly substitute that into the top equation, you just get x plus 11 equals 29. So subtracting 11 from both sides, you're just going to instantly get x equals 18. And that's our final answer. All right, this one's talking about a table. Which table gives 3 values of x and their corresponding values of y for the given equation? Any answers in the chat? Let me check. A. Yeah, A is correct. We want something that has a y-intercept at 4. So when x equals 0, y has to equal 4. And if we just go off that criteria, we can actually eliminate all of the answer choices. But just to make sure, we would want to check that the slope matches up with the slope of 1. And definitely we see for every increase in x, we go up in y by 1 as well. Okay, pretty easy there. And we've got another math question down here, but it's more like interpreting a graph. It says that Teresa ran on a treadmill for 30 minutes. Her time and speed are shown on the graph above. According to the graph, which of the following statements is not true concerning Teresa's run? A, she ran at a constant speed for 5 minutes. I mean, I think I do see that right here, right? She ran for between 5 and 10 minutes at a constant speed. So that is true. It's kind of hard when you have these that ask about not true. You kind of have to label which ones are true. I see answers in the chat. Yep. Teresa's speed was increasing for a longer period of time than it was decreasing. So let's see. It was increasing for 5 minutes plus 5 minutes. So it was increasing total of 10 minutes. It was decreasing for 10 minutes right here and 5 minutes right here. So it was decreasing for 15 minutes. So actually B would be the right answer here. It's not true that her speed was increasing for a longer period of time. It's actually decreasing for longer. C is true, right? Speed decreased at a constant rate. That's a linear slope. And it's reached its maximum during the last 10 minutes. That's also true. So by process of elimination and just matching that up, we get answer choice B for this one. B, yeah. We've got a few more questions for you guys, and then I'll ask you guys to send in your own. Had to throw in a reading question, of course. It's a bit lengthy, but we can do this one. Not too bad. It says, while researching a topic, a student has taken the following notes. Actually, let me skip that. Let's actually read the question. It says the student wants to summarize the kelp highway hypothesis. Okay, so now I know what to focus on when I go back and read this. Which choice most effectively uses relevant information from the notes to accomplish this goal? Well, from the notes, let me just read through all these bullet points. Archaeologists' colleagues argue humans first arrived in the Americas by sea. They propose humans traveled between the Pacific Ocean islands and coastlines from Northeast Asia to the Americas. Many of these islands were later submerged. They think a coastal route, including kelp forests and estuaries, would have provided a rich mix of marine, estuarine, riverine, and terrestrial resources, such as seaweeds, fish, and birds. This proposed scenario is known as the kelp highway hypothesis. All right. We want to summarize the kelp highway hypothesis. It looks like humans traveled across the sea. They had a coastal route which had a lot of resources. So let's look at something, see if anything matches there. Pacific Ocean islands and coastlines likely contain a rich mix of resources. That seems like a reasonable answer choice. One argument about humans first arrived in the Americas is the kelp highway hypothesis. Well, that mentions the keyword, but it doesn't summarize. We need to summarize the hypothesis. Humans may have first arrived in the Americas by sea, traveling between Pacific Ocean islands and coastlines and subsisting on a variety of resources. Yeah, that one could work. Between A and C, those could both work. D, as glaciers melted and sea levels rose, many islands were submerged. That's not really summarizing the whole hypothesis, it's just one small detail. So ultimately here, I think what we're going to want to go with for this reading question. What do you guys think? I'm going to check chat. People saying A, C. Looks like for this one, it's going to be answer choice C. Humans may have first arrived in the Americas by sea. That's what we see. Let me actually point out where we see all of these details. Detail 1, detail 1. Traveling between Pacific Ocean islands. That's detail 2. And coastline, and subsisting on a variety of resources. Variety of resources, that's detail 3. We have all of the details that we need. For A, it sounds pretty good, but it's actually pretty specific. A is just specific to these last couple of bullet points, but answer choice C actually matches with all of those points simultaneously. That's why it would be the best answer choice. Yeah. But good job on these ones. Let's keep moving on. We have a math question next, which I always like. It says triangle ABC is similar to triangle DEF. I'm immediately drawing this because it helps me visualize. If two triangles are similar, then they have the same proportions, or the side lengths are proportional, but they might just be scaled up or down, and the angles should stay exactly the same. A corresponds to D. I mean, yes, I have that. And C corresponds to F. C and F. Yes, I also have that. Then C and F are right angles. Okay, maybe I drew this a little bit too quick. Let me revise this. If C and F are right angles, it's actually going to look more like this. Let me erase that. Then we'll mark those as right angles. I'll have D, E, F. Tangent of A is 50 over 7. That's the opposite over adjacent. So we're saying tangent of A is equal to 50 over 7. That means this is 50, this is 7 by our side length ratios, right? Because if you think about SOHCAHTOA, assuming you guys have done trig before, since I don't have a ton of time to explain it, but tangent of an angle is the ratio of the opposite side to the adjacent side. And so the opposite side is 50, the adjacent side is 7. Then it's asking for the value of tangent of E. But E is up here. E, that would mean this is the new opposite. This is the new adjacent. So it's kind of like flipped almost. Actually, it is flipped. Tangent of E, from this perspective, the opposite side is now 7. And the adjacent side is now 50. So it's final answer, 7 over 50. Did we get that one? Hopefully. And I've got another math question for you guys. It says if A and C are positive numbers, which of the following is equivalent to the square root A plus C cubed plus square root A plus C? Well, so one rule that you guys should know for the SAT, or you need to know, is that if you have two things under separate square roots, you can multiply them under one root, kind of like this. Meaning I'm going to multiply everything here under one square root as a plus c cubed times a plus c. And we can further combine that. I mean, this is just 3 copies of a plus c, and this is 1 copy of a plus c. That's going to give us a plus c to the 4th power. And if we square root something to the 4th power, that's going to reduce it to just a plus c squared. Another way you can think about that is the square root as a fractional exponent, as a 1/2, and multiplying that into 4 would give us 2 as well. A plus c squared, that's actually not one of the answer choices. B is kind of close, but it's wrong. D is wrong, which means we might need to expand this out as our final step. That's just a plus c times a plus c if it's squared, and that makes it, if we use FOIL, a squared plus 2ac from the outer and the inner terms, and then plus c squared. That does match up with answer choice C. And I think you guys got it in the chat. Yeah. I think that's the questions that I've got for you guys today. Feel free to submit some in the chat. I'll paste them in and we'll do them together. I have a lot of space here. Ooh, maybe you could send a screenshot, like a PNG. Oh, wow. These are some tough problems. All right, yeah, thanks for sending these in. Let me check earlier if I missed anything. I see this one right here. I see another problem right here I'm going to paste in. Oh my god, that's huge. Starting with send. Okay. If you can send a screenshot, I can paste it in here. Otherwise, it's a bit tough. But let's take a look at this one. When the function p of x is divided by x minus 1, the quotient is x squared plus 7 plus 5 over x minus 1. State p of x in standard form. Well, if p of x, let me write it out like this. Maybe it'll be clear. P of x divided by x minus 1 is equal to x squared plus 7x plus 5 divided by x minus 1. If we just want to solve for p of x, well, we just need to multiply everything by x minus 1. And that's what I'm going to do here. Multiply this whole thing by x minus 1. Multiply this whole thing by x minus 1. You'll see it'll cancel out on the left side, and it'll leave us with just p of x on the left. On the right, you're going to have to do a little bit of distributive property. So x squared times x will give us x cubed. X squared times -1 gives us minus x squared. Then 7x, I could do it in different colors if that makes it easier. That will give us x cubed. That gives us minus x squared. That gives us plus 7x squared and minus 7x. And then this one gives us plus 5x over x minus 1. And then minus 5 over x minus 1. So I can start to combine some of these things. That means p of x is equal to, well, x cubed can't be simplified. It's the largest term. But we have minus x squared and plus 7x squared. That'll be plus 6x squared. Here we have minus 7x, so let's just keep that. Here we have 5x and minus 5 all over x minus 1. I can actually combine that under the same denominator. And that's the same thing as, notice how that's the same thing as 5 times x minus 1 divided by x minus 1. So the x minus 1's cancel out. The standard form here finally should be x cubed plus 6x squared minus 7x plus 5. Box it in green because I like green. Makes sense? Nah, you said I copied it wrong. That's an easy fix though, because we go back here, take away the x. Instead of 7x squared, it's 7x here, minus 7 here, and we can quickly just correct some of our work. This all stays the same. So the minus 7 becomes minus 7x. Oh. How did I have it before? Okay, it becomes a little bit confusing to copy. Basically, that doesn't combine anymore. That's just minus x squared. We have plus 7x, and then we have the minus 7 plus that. Right, plus 7x minus x squared. And we have to remember the minus 7 here. So if that cancels out, we get minus 7 plus 5. Minus 7 plus 5 is going to be minus 2, so we get in total x cubed minus x squared plus 7x minus 2. Now we can, I really want to make sure that this is correct. So we can actually like graph this out in Desmos and just make sure. But let me check. Oops. Oh, shoot. So the, oh. X cubed minus x squared plus 7x minus 2. Take that whole thing, divide it by x minus 1, and make sure it's the same as what we're given, which is x squared plus 7 minus plus 5 over x minus 1. Yeah, it's the same thing. So now we definitely did it right. Copy this one in. Why is that one so huge? All right, hopefully that one makes sense for you guys. On to our next one. Which says, yeah, if you have more pictures, definitely send them in. I'm gonna keep adding them to the board. While you guys read this out, I need to take a drink of water. Because it gets hard talking all the time. Let's see, we got z of x. We have z of 2. We have z of negative 5. We need to algebraically determine all of the zeros of z of x. Okay. I mean, one thing we could do is try to find this b value, this missing value. if we have z of -5, that's equal to 6 times -5 cubed plus b times -5 squared minus 52 times -5 plus 15. That's all equal to 0. That's one of the zeros, by the way, we already found. And there's going to be 2 more, because this is a third-degree polynomial. Well, I'll do a different color here, like purple. 6 times -5 cubed is going to be 6 times -125, so that's going to be around -750. This is going to be plus 25b. 52 times 5 is going to give us 260 here, and plus 15. This all equals to 0. And if I isolate everything, I keep 25b right here, then I would move 750 onto the other side and subtract 260 and 15 to get 25b equals 475. Divide by 25 to get b equals 19. So there's our b value. I don't know what we need this for exactly. Maybe we could have used that to solve, but let me list the zeros up top here. Zeros are going to be -5 as the first one. We know that one is going to be a 0 because it tells us the function at -5 is 0. How are we doing so far? Questions? The other ones, a little bit trickier. I'm a little bit rusty, but you could do synthetic division and get a quadratic polynomial. You could do even long division, which is probably what I'm going to do because that's the only way I remember to do it. But if we know that one of the zeros is at -5, that means, let's see, if the 0 is at -5, that means that x plus 5 is a factor. That would mean it divides evenly into that function. So something like 6x cubed plus 19x squared minus 52x plus 15. That's actually divisible. It's actually going to be divisible by x plus 5. And we can look, x plus 5 goes into 6x cubed. It's going to go in 6x squared times 6x squared. Since the leading term x multiplied by 6x squared will give us back to 6x cubed. So now I could subtract the multiplication of these two. It's going to be 6x cubed plus 30x squared. If I subtract that out, these cancel, and this remains, which is -11x squared. So how many times does this go into -11x squared? It's going to be minus 11x times. And if I multiply this and this together and subtract that out, we make sure to bring this term down as well. We're going to get minus, that's at -11x squared minus 55x. Well, subtracting these terms from each other, cancel them out. Subtracting a -55x is like adding 55x. So that'll give us to 3x. Last thing I do is I bring this term down. It's 15. And I check how many times does x plus 5 go into 3x plus 15. That's exactly 3 times. So minus, so I subtract the product of those, and that's going to be 3x plus 15, leaving us after this division, after all the division, with a remainder of 0, which means that this is indeed a factor, and this is the remaining polynomial. So from here, we have hidden in here the remaining roots. We would just, there might be a way to factor this out, but I don't really see it. So what I'd like to do instead is just use quadratic formula. And that tells us that x is negative b plus or minus the square root of b squared minus 4ac all over 2a. Or that those roots, those zeros are going to be 11 plus or minus 4 times 6 times 3 will give us 72. And 121 minus 72 will give us 49. So under the square root we have 49. Here we have 12. It's 11 plus or minus 7 over 12, which is either 18 over 12, and 18 over 12 is just like 1.5, or 4 over 12. 4 over 12 is 1/3. So it's either 3/2 or 1/3, assuming that I did the math correctly. So back to the question of all the zeros of z of x. The zeros are going to be -5, 3/2, and 1/3. Questions? All right, I trust you guys. I trust that you followed along everywhere. And just to do a little sanity check, let's plot that one out and see if we got the zeros correctly. Because it's possible we made a mistake. We get -5, 1/3, and 3/2. So it looks like everything is good there. Yeah, you can ask questions. Just send me an image so I can paste it into the whiteboard. Makes it much easier for me. Try to crop it if you can. This one's a bit tough. All right, this one, someone submitted this one about simultaneous equations. So let's go through that. So next one. All right, we have 3y minus 2x equals 5. The way it's set up, I'm immediately looking for some way to cancel some of the stuff out. One thing I see is if I multiply this bottom equation by -3, 3y minus 2x equals 5. If I multiply that bottom one by -3, I could get my y terms to cancel out. So like, watch this. -3 multiplied by y plus 5x equals 13. What that's going to give me, let's do it like this. I don't know what I'm drawing there. Arrow. It's going to be 3y minus 2x equals 5. And on the bottom, if I multiply everything by -3, that's -3y minus 15x equals -39. So if I add that all together, you'd see how this cancels out and just gives me -17x equals -34, which means if I divide by -17, I get x equals 2. Then I just need to plug it back into this bottom equation, or any equation really. Or we know that y plus 5x equals 13, which means that y equals 13 minus 5x. And since we just found that x is equal to 2, we get 13 minus 5 times 2, or 13 minus 10, which is 3. So the solution x comma y is actually equal to 2 comma 3 for this one. Thank you to whoever submitted that question. Got another question here. SAT. Yeah, I've heard about the SAT. What about it? Tips. Honestly, I would just do practice tests and see what you're. I kind of approach it like the same way as the SAT. See what you're lacking in. Ooh, this is a rough picture, but it's okay. I think Josh, you submitted that one. We'll do that as our last question. So I have a few more questions here. The next one that I have in line for you guys is solving an inequality. X over 2 minus 7 less than 3 less than or equal to 2 minus x over 5. Oh, like, okay, let's do it. Probably black is the best on this background. What I'll do, what I want to do here is add 7 to everything because I want to get rid of this minus 7. So I get x over 2 is less than 10 is less than or equal to 2 minus x over 5 plus 7. Then I want to get rid of these fractions. So I want to multiply everything by a common denominator of 10. That would give me here 5x is less than 100 is less than or equal to 2 times 2 minus x plus 70. Well, let me just rewrite that really quick to get 4 minus 2x plus 70. Simplify that even more to get 5x less than 100 less than or equal to 74 minus 2x. Dang, so where do we go from here? Well, I don't know, you guys. I don't know, you guys. There's a few different steps we could do. One thing that's easy for us to do is plot this one out and see if we can get some more intuition. No. So, purple region and the black region. It looks like after a certain point, the black region is our limiting factor, which is this part of the equation. So 5x, yeah, I guess we can just solve these as two separate cases, right? We have case 1 right here. Oh, that's not readable. Case 1 right there, and we have case 2 right there. Right, this first one, 5x less than 100, just means that x has to be less than 20. This other one right here, the case 2, is going to tell us that 100 is less than or equal to 74 minus 2x. Right, so if we add 2x on both sides and subtract 100, 2x less than or equal to, I hate doing this kind of subtraction, minus 26. Divide by 2 and get x is less than or equal to negative 13. Both of these are less than or equal to constraints. So this is going to be the dominating factor. X is less than or equal to negative 13. If you had to plot out on a number line, here's 0, here's negative 13. You just make a closed circle and the solution would keep going towards negative direction. I hope that's clear. Okay. Bonus problem. Who submitted? Who's making me do their homework? All right. X squared minus 8x plus 80 as a product of linear factors. Yeah, that's a fancy way of saying factor this. Factoring is going to be something that, well, the leading terms are going to be x, and something that multiplies up to 80 and adds up to -8, which is going to be, let's write the factors of 80 of 1, 2, 4, 10, sorry, 8, 10, 20, 40, 80. I also forgot 5 and 16. So like 4 and 20 will multiply to 80, 8 and 10 will multiply to 80, but we want something that adds up to -8. 5 times 16 multiplies to 80, but is there something I'm forgetting? Is there one I'm missing? See, because I don't see one that would multiply evenly. 80 by 6? No, that's not it. Then what am I missing here? Let me try graphing it on Desmos very quickly and seeing if I can get what I need. Okay, so that's x squared minus 8x plus 80. Oh, I see. This is not going to have any real factors or real solutions. It's going to be complex. So what I could do is just apply quadratic formula and solve it that way. I'll show you how to do that. We would get the x values are going to be, right, the quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. I hope you guys remember that one, which in this case, that's going to be 8. Here, let's write it out. It's going to be 8 plus or minus the square root of 8 squared minus 4 times a times c all over 2 times a. Simplify that out a little bit further. 8 plus or minus 64 minus 320. Anybody do that in their head? 64 minus 320 is negative 256. Now you see where the problem arises, is this square root of a negative number. But square root of negative 256 is just going to be 16i. Square root of negative 1 is defined as I. So we solve it out like that. Divide everything by 2 and we get 4 plus or minus 8i. So we could write this out as, these are our two factors. It's going to be x minus 4 plus 8i, or x minus 4 minus 8i. That's the same thing as x minus 4 minus 8i times x minus 4 plus 8i. I would say this is probably your final solution here. Square root of negative 1 equals I, then I squared equals 1. No, I squared equals negative 1. Yeah. I got couple more questions here. We've got helicopter problem. Left airport at noon and flew east at 110 kilometers per hour. So at the same time, an adjacent runway, a light plane left mid-city flying east at 320 kilometers. How far apart were the aircraft at 2:30 p.m.? Well, let's see. If we want to write distance equation for each aircraft travel, the distance of the helicopter is going to be 110 kilometers per hour times the number of hours. the plane is going to be 320 kilometers per hour times the number of hours. So let's say these are the two equations. To relate the distances to each other, what I would say is the difference in a distance is going to be the plane's position minus the helicopter's, which is going to be 320t minus 110t. And specifically at time equals 2:30, that's 2.5 hours. That's going to be 210t at, all right, 210t. Yeah, distance at 2:30 p.m. is going to be 210 times 2.5. Should be, I think, 525 kilometers. Make sense? Yeah, d equals rt. Distance is equal to rate of travel times the time traveled. Oh, maybe for a future reference, try to submit some questions that are a little bit clearer. But I saw someone needed help with part B on this one. What is the side length to the nearest hundredth of an inch of all the cut square that produces the maximum volume? Are you guys in calculus? Yeah, I'll send a PDF for this afterwards. Who submitted this? Josh. Is this a calculus question? All right. So yeah, function to model the volume of the box that she created. She has a paper 8 by 12 inches. She cut out squares of side length x from each of the four corners and created a box with an open top. So the volume of the box is equal to 12 minus 2x, 8 minus 2x times x. Yeah, that's correct, right? That's the side length of from here to here. There's a side length there, and that's the height of the box. So we want to find the side length to the nearest hundredth of an inch of the cut square that produces the maximum volume. Well, unless you're going to graph this to find the minimum, you could graph this, and that would be the easiest choice, right? That's going to be 12 minus 2x, 8 minus 2x, x. You find that your minimum volume would either be at x equals 0, x equals 4, x equals 6. Wait, sorry, we're trying to find the maximum volume. The maximum volume is around x equals 1.569. Which you could also do this with calculus. So if you wanted to find those critical points, you would set the derivative equal to 0. I would have to probably multiply this whole thing out, which is a bit lengthier. Multiply out and then find the derivative and then set derivative equal to 0 and solve for your critical points. That would get you to this. I'll let you guys do that. Oh, sorry. Oh, well, yeah. The solution for this is then going to be to the nearest hundredth of an inch. The answer for this is just going to be x equals to 1.57. Yeah, I'm going to share it. Yeah, unfortunately, I don't have any space for the other questions, but this will be on my YouTube. You guys can save your questions for next week as well, and I'm going to post a PDF. So thank you guys all for joining. Make sure to check out my Explore page, explore.advancedtestprep.com. I have a weekly newsletter where I give helpful SAT tips, and also all the Tutor Tuesday should probably be on there. Let me know if there aren't. But all the PDFs of previous sessions I post. Yeah. Thank you guys. I will see you again next week.